SwayamPrabha. Digital India. Educated India.
Sizing effluent treatment, lecture number 13. Let us now look at specific effluents from specific processes and how their treatment is carried out. Sizing agents. The traditional sizing agent is starch. However, in recent years, the trend has been towards synthetic sizes for upgraded size performance. Brief description of the function of various sizes used is given here. Starch. Granular starch consists of alpha and beta amylose. The former is insoluble in water, whereas the latter is soluble. The beta amylose is contained within a membrane of the alpha amylose. On heating, water permeates through the outer membrane, causing the beta amylose to dissolve and swell. The granules become expanded and the viscosity increases. Excessive temperature or agitation causes the alpha amylose membrane to be disrupted or ruptured, leading to a decrease in viscosity. Many starches form an irreversible gel on cooling. Reheating the gel with strong agitation causes redispersion. However, small pieces of gelled particles tend to remain. By substituting acetyl or hydroxyethyl group for hydrogen or hydroxide group on the starch molecule, modified starches are formed. These have lower and more stable viscosity characteristic. Modified starch adhere more strongly to synthetic fibers than does native starch. Even the modified starch films are not very water soluble, and in order to remove the size from the fabric, enzymes are used to degrade the starch into soluble sugar. So, starch has been a popular sizing agent, and we have seen that it is one of the first processing stage of any fabric or yarn, which in the textile processing we had learnt. Starch is one of the traditional main sizing agent. Commonly used starches are edible, including wheat, potato, maize, sweet potato, indica rice and tapioca. Among them, maize and wheat starch has better sizing performance and can be used for wrap sizing, warp sizing of fine meter, high density cotton. Non-edible starch such as acorn starch can also be used as sizing materials. Starch swell in water as the temperature increases, gelatinizes into a slurry and forms a gel after the temperature decreases. The starch slurry is only suitable for sizing after gelatinization and higher than the gel temperature. The fluidity of starch slurry is poor. The viscosity is not stable enough. The cerosol film is brittle and hard, and it is easy to be corroded or corrupted by microorganisms. Therefore, it must be equipped with auxiliary slurries such as softeners, surfactants, starch decomposition agents and preservatives. Starch contains a large number of hydroxyl group and has good adhesion to cotton, hemp, viscose and other fibers that also have large number of hydroxyl groups. The starch slurry has good mechanical properties after drying to form a film. Various starch derivatives such as oxidized starch containing carboxyl group, water soluble starch ethers such as carboxymethyl starch, starch esters such as starch acetate, cationic starch, grafted starch, etc., are widely used in various yarns sizing. Role of starch as sizing agent. Starch is one of the widely used sizing agent in textile processing, particularly in the weaving of natural fibers such as cotton and linen. Its role is multifaceted and crucial in achieving desirable fabric properties. Here are some key aspects of the role of starch as a sizing agent. Enhancing yarn strength. Starch forms a film around individual yarn fibers, increasing high strength and cohesion. This helps to prevent yarn breakage during weaving, resulting in smoother production processes and higher fabric yields. Improving weavability. By imparting lubricity and smoothness to yarn surfaces, starch reduces friction and abrasion during weaving. This facilitates the movement of yarn through the loom, reducing the likelihood of snags, tangles and other weaving defects. So, starch has a very major role to play as a sizing agent, and we have seen that it enhances yarn strength, it improves the weavability, that is, it increases the ability for the yarn which has been sized to be woven properly. Controlling yarn hairiness. Starch sizing agents can help minimize the tendency of yarns to become hairy during weaving. Excessive yarn hairiness can lead to surface defects in the fabric and compromises its appearance and quality. Starch helps to maintain yarn smoothness and integrity, resulting in cleaner and more uniform fabric. So, it can control the hairiness, providing temporary stiffness. Starch sizing imparts temporary stiffness to the yarns and fabric during weaving, aiding in the formation of sharp selvages and improving fabric handle. This stiffness is desirable during weaving, but can be easily removed during subsequent processing steps such as desizing and finishing to achieve the desired fabric softness and drape. So, temporary stiffness also it can provide, and which eventually in the desizing step or in the finishing step is removed. But for the time being it gives a good handle to the fabric. Cost effectiveness. Starch is a cost effective sizing agent compared to synthetic alternatives, making it a preferred choice especially for mass produced textiles. It is readily available, biodegradable and compatible with existing textile processing equipment and methods. Environmental consideration. Starch sizing agents are generally considered environmentally friendly as they are derived from renewable plant resources. They are biodegradable naturally and do not contribute to pollution or environmental harm when disposed of properly. In summary, we can say starch plays a vital role as a sizing agent in textile processing, contributing to improved yarn strength, weavability, fabric quality and cost effectiveness. It is versatility, effectiveness and environmental friendliness that makes it a preferred choice for a wide range of textile application. So, we understand that starch has all the attributes that is required for a good sizing agent. Then comes the next sizing agent, which is carboxymethyl cellulose, CMC, is formed by treating cellulose with sodium hydroxide and monochloroacetic acid. The two properties which can be varied are degree of substitution and molecular weight. Solutions of CMC maintain their viscosity for up to 24 hours. Sodium and potassium salts do not affect the viscosity, but calcium, iron and aluminum salts form gel-like precipitates. Warp sized with CMC can be woven at lower humidities than starches. The CMC film readily dissolves in water and desizing can be accomplished by hot water wash. CMC is a commonly used sizing agent in textile processing, offering several benefits and functionalities in the production of high quality fabric. Here is an overview of its role. Film formation. CMC forms a thin uniform film on the surface of the yarn, providing lubrication and reducing friction during weaving. This helps to prevent yarn breakage, snags and other weaving defects, thereby improving the efficiency of the weaving process. Enhanced weavability. By reducing the coefficient of friction between yarns, CMC improves the weavability of fibers, allowing for smoother yarn passage through weaving machine. This results in reduced downtime, higher weaving speeds and increased fabric production rates. So, CMC has its own benefit and we saw starch had its own benefit. But when we want to have very fast weaving and increase fabric production, then CMC is the choice. Control of hairiness. CMC helps to maintain yarn hairiness by smoothing the surface of individual fibers. This reduces the occurrence of surface defects in the fabric, results in cleaner, more uniform appearance. Temporary stiffening. Similar to starch, CMC imparts temporary stiffness to yarns and fabrics during weaving, aiding in the formation of sharp selvages and facilitating the handling of fabrics on looms and during subsequent processing steps. So, just like starch, even CMC can give temporary stiffness, which is required for handling at that stage. Improved fabric properties. CMC sizing agents can enhance the properties of fabric such as dimensional stability, tensile strength and abrasion resistance. This contributes to the overall quality and durability of the finished textile product. So, there is enhancement in property when CMC is used as a sizing agent for treating the fabric, and these enhanced and improved factors are: it gives a dimensional stability, it improves the tensile strength and it is abrasion resistant. Compatibility with other chemicals. CMC is compatible with a wide range of textile chemicals and processing conditions, making it versatile and easy to incorporate into existing textile processing operations. Environmental consideration. CMC is derived from cellulose, a renewable and biodegradable natural polymer, making it environmentally friendly compared to some synthetic sizing agents. It is non-toxic and does not pose significant environmental risk during manufacturing or disposal. Overall, carboxymethyl cellulose plays a crucial role as a sizing agent in textile processing, offering benefits such as improved weavability, reduced yarn breakage, enhanced fabric properties, and environmentally sustainable. Its versatility and compatibility make it valuable choice for the various textile applications from apparel to home textile to industrial fabrics. Then comes the next sizing agent, which is polyacrylates. Polyacrylate sizes, that is PAA, are based on salts of polyacrylic acid. The two most commonly used are sodium and ammonium salts. Acrylate sizes have high adhesion than starch, CMC or polyvinyl alcohol. They are suitable particularly for nylon and polyester. The humidity in the weaving shed must be controlled, as these sizes become sticky and lose film strength at high humidities. They are very soluble in water and can be removed from the fabric with ease. So, polyacrylates are mainly used for the nylon and polyester for sizing as a sizing agent. Polyacrylates are known as acrylic polymers, are used as sizing agents in textile processing, offering unique advantages and functionalities. Here is a look of what all they can do in their role. Film formation. Polyacrylate can form thin uniform film on the surface of the yarns, providing lubrication and reducing friction during weaving. This helps to prevent yarn breakage and weaving defects, improving the efficiency of the weaving process. So, because it can form very even film, it is very good and forms a uniform film on the surface of the yarn, providing lubrication and reducing friction during weaving. Improved weavability. By reducing the coefficient of friction between yarns, polyacrylate enhance the weavability of fibers, allowing for smoother yarn passage through weaving machinery. This results in reduced downtime, increased weaving speed and higher fabric production rates. So, if it is very smooth, it will weave very well. If it weaves very well and has a good speed, then increased weaving speeds will happen and higher fabric production will definitely take place. Control of hairiness. Polyacrylates help minimize yarn hairiness by smoothing the surface of the individual fibers. This reduces the occurrence of surface defects in the fabric, resulting in cleaner and more uniform appearance. Enhanced fabric properties. Polyacrylate sizing agents can improve various fabric properties, including dimensional stability, tensile strength and abrasion resistance. This contributes to overall quality and durability of the finished textile product. Stiffness and handle. Polyacrylates can impart temporary stiffness to yarns and fabric during weaving, aiding in the form of sharp selvages and facilitating fabric handling on looms and during subsequent processing steps. So, just like CMC, even polyacrylates can give the desired qualities. Versatility. Polyacrylates offer versatility in formulation and application, allowing customization to meet specific textile requirements. They can be tailored to achieve desired levels of stiffness, lubricity and compatibility with other processing chemicals. Environmental consideration. While polyacrylates are synthetic polymers, advancement in polymer chemistry have led to development of environmentally friendly formulations. Biodegradable and eco-friendly versions of polyacrylates are available, reducing environmental impact. So, now with the technological advancement, even the polyacrylates which are polymer, which were thought to be non-biodegradable, have been made and converted into polyacrylates which are biodegradable. And this eco-friendly version of polyacrylates is very much desirable because it reduces the environmental impact. Overall, polyacrylates play a crucial role as sizing agents in textile processing, offering benefits such as improved weavability, reduced yarn breakage, enhanced fabric properties and versatility in formulation. Their use contributes to the production of high quality textiles across various applications, from apparel to home textiles to technical and industrial fabrics. Then comes the next sizing agent, polyvinyl alcohol. Polyvinyl alcohol is produced by acid or alkaline hydrolysis of polyvinyl acetate. The two chemical properties that can be manipulated during the manufacturing processes are degree of polymerization or molecular weight and degree of hydrolysis or the fraction of sites that have OH group attached on them. So, because it is made from polyvinyl acetate, the acid or alkaline hydrolysis, the degree of hydrolysis will yield that many OH group free. Polyvinyl alcohol PVA as a sizing agent is widely used in textile processing, particularly in application where water solubility and environmental compatibility are essential. And here is how PVA functions as a sizing agent. Film formation. PVA forms a thin cohesive film on the surface of the yarn, providing lubrication and reducing friction during weaving. This film helps to prevent yarn breakage and abrasion, resulting in smoother weaving operations and higher fabric yields. Enhance weavability. By reducing the coefficient of friction between yarns, PVA improves the weavability of fibers, allowing for smoother yarn passage through weaving machinery. This leads to reduced downtime, increased weaving speeds and improved fabric quality. So, all of them, see, you must have seen that if it, whether it is CMC or whether it is polyvinyl alcohol or polyacrylate, all of them have this very good quality of film formation, and because of that there is enhanced weavability. Control of hairiness. PVA sizing agents help minimize yarn hairiness by smoothing the surface of the individual fibers. This results in cleaner, more uniform appearance of the fabric, reducing the occurrence of surface defects. Temporary stiffness. Similar to other sizing agents, PVA imparts temporary stiffness to yarns and fabrics during weaving, facilitating the formation of sharp selvages and improving fabric handle. This stiffness can be easily removed during subsequent processing steps such as desizing and finishing. So, most of the phenomena are similar, and you will see that here also there is temporary stiffness, control over hairiness, etc. Compatibility with other chemicals. PVA is compatible with a wide range of textile chemicals and processing conditions, making it versatile and easy to incorporate into existing textile processing operations. It can be used in combination with sizing agents or finishing chemicals to achieve specific fabric properties. Biodegradability. PVA is biodegradable, meaning it can be broken down by microorganisms in the environment over time. It makes it environmentally friendly or eco-friendly choice compared to some synthetic sizing agents, as it does not persist in the environment after use. Water solubility. One of the key advantage of PVA is its water solubility, which allows for easy removal of the fabric during subsequent processing step. This ensures that residual sizing agents do not affect the final properties of the fabric and enables efficient desizing without the need of harsh chemicals. Overall, polyvinyl alcohol plays a crucial role as a sizing agent in textile processing, offering benefits such as improved weavability, reduced yarn breakage, enhanced fabric appearance, and environmental compatibility. Its water solubility and biodegradability make it a preferred choice for a wide range of textile applications, from apparel to home textiles to technical and industrial fabrics. So, it becomes quite a commonly usable sizing agent because of its attributes. It is soluble, it is biodegradable, and at the same time it improves the weavability, reduces the yarn breakage, and gives an enhanced fabric appearance. So, what more can one ask? All the attributes can be achieved by using PVA, polyvinyl alcohol, as a sizing agent. Now, let us look at some of the other not so popularly known sizing agent, and one of them is distillers dried grain, DDGS. Distillers dried grain, that is maize, the co-product of corn ethanol production, were used as a textile sizing agent on cotton, polyester and polyester cotton blends in an effort to find inexpensive and biodegradable or alternative to sizing agent such as polyvinyl alcohol that are currently used. Although DDGS is an inexpensive, biodegradable and abundant co-product, it has limited industrial application. DDGS is a mixture of carbohydrate, protein and oil which are used as sizing agents or as size additives. DDGS maize that was extracted in 0.5% alkali concentration solution for 1 hour was most suitable for textile sizing, based on the improvement in the strength and elongation of rovings and fabric abrasion resistance. The main advantage of DDGS is that the chemical oxygen demand, that is COD, of DDGS size decreases 80% in 3 days compared to 25% for PVA, demonstrating that DDGS was easily biodegradable in activated sludge. Good sizing performance and easy biodegradability demonstrate that DDGS based sizes have potential to serve as an environmentally friendly sizing agent. More and more environmentally friendly sizing agents are on search. One is looking for such compounds because then sizing agents and the pollution created by sizing agent can be overcome because they are biodegradable. Now, technical comparison among maize starch, PVA and WSP resin, which is a synthetic sizing agent. So, one is from the plant, the other one is from a polymer origin, but it has been modified, and the other one is a polymer totally. So, if we look at this chart, we see that when we look at the parameters of flexibility, penetration, viscosity, size, abrasion resistance, hairiness control, desizing, cyclability, residual elongation, solubility in size mix, effluent COD and BOD, and surface smoothness and softness of size film, then we see that maize starch had poor flexibility and PVA had kind of so flexibility, but WSP resin had very good flexibility. Similarly, penetration also the similar type of grading. Viscosity size, maize starch was high, PVA was high, but WSP resin was low. Abrasion resistance was low for maize starch, but was high for PVA and very high for WSP resin, and the same trend was seen in hairiness control. Desizing difficult for maize starch, PVA not so easy, but WSP resin was very easily desized. Similarly, if we see the solubility, it is the same trend as what we saw in the flexibility. But when we look at the effluent COD and BOD, we see for maize starch it is low, for PVA it is high, but for WSP resin it is low. So, considering these points, one can say that modified sizing agents also have some scope. Now, let us look at modified sizing agent. Evaluation of sizing parameters of cotton using the modified sizing agent and the frequently used sizing agent in the industry was carried out. For modification of sizing agents, various sizing chemicals are mixed together in their own developed recipe. Then modified sizing agents were applied to cotton fabric along with frequently used sizing recipes. The result indicated that the modified sizing agent has an acceptable range of sizing parameters, and even in some cases the performances are higher than the frequently used sizing agents. The recipe of modified sizing agent containing Ecacell DT 250 or Ecaviol Bez and Ecavax chemicals. The most important thing that the modified sizing agent reduces the chemical consumption as well as makes cost effectiveness of weaving production, which is definitely more economical and economically sustainable development in the textile industry. So, these modified sizing agents are very good in terms of their cost effectiveness. Sizing agents play a role in textile processing, particularly in weaving operations where yarns are subjected to tension, friction and abrasion. And here is a breakdown of their importance and usage. Improving weavability. Sizing agents, as we saw earlier also, that they improve the weavability or are used for improving the weavability, I should say. See, sizing agents are applied to warp yarn to enhance their strength, smoothness and cohesion, making them more resistant to abrasion during the weaving process. This prevents breakages and improves the overall efficiency of the weaving operation. Reducing friction. Sizing agents reduce the friction between yarns, which facilitates smoother yarn passage through the weaving machinery. This minimizes yarn breakage and ensures consistent fabric quality. Control of hairiness. This also we saw that most of the sizing agents that we studied just now had all the properties that an ideal sizing agent should have, and one of them is the control of hairiness. Sizing agents can help control the tendency of yarns to become hairy during weaving, which can lead to quality issues such as surface defects and reduced fabric strength. So, that is why if there is a control on hairiness, that sizing agent is ideal. Enhancing fabric properties. Sizing agents can impart desirable properties of the fabric, such as stiffness, smoothness and improved appearance. This can result in fabrics with better drape, handle and overall aesthetics. Facilitating post-processing. Sizing agents are designed to be easily removed from the fabric during subsequent processing steps such as desizing and finishing. This ensures that the fabric's final property are not adversely affected by residual sizing agent. So, the sizing agent should be such that it should not leave too much of residual sizing agent on the surface, because that would affect directly on the final property and look of the fabric after the sizing process is conducted. Common types of sizing agents include starches, synthetic polymers such as polyvinyl alcohol and blends of various compounds tailored to specific textile applications. The choice of sizing agent depends on factors such as type of yarn, weaving condition, desired fabric properties and environmental conditions. Overall, sizing agents are essential components in textile processing, enabling the efficient production of high quality fabrics while optimizing the performance of the weaving machinery. Warp sizing. Warp sizing is a process of applying sizing agent to the warp yarn to improve its weavability. Warp and weft are the two different types of yarn which are intercalated to make a fabric, and so warp is mainly sized. Weaving ability refers to the performance of the warp yarn and can withstand repeated friction, stretching and bending of warp stoppers, heels, reeds, etc. on the loom without causing a lot of fluffing or even breaking. The single yarn fiber without sizing are not tightly entangled with each other, and the surface hairiness is more, and therefore it becomes difficult to weave. Therefore, sizing is necessary and warp sizing is equally necessary. After sizing, a part of the sizing liquid penetrates between the fibers and the other part adheres to the surface of the warp yarn. The sizing, mainly composed of the sizing liquid penetrating between the fibers, is called impregnable sizing. and the sizing mainly composed of the sizing liquid adhering to the surface of the warp is called the covering sizing. The sizing operation is the link between yarn making, weaving and finishing. It has a significant effect on quality and processing cost in the sizing process. So, warp sizing is very important. Why? Because it happens in two different levels. One is that the sizing liquid penetrates between the sizing and it is called impregnable sizing, whereas sizing agent can cover the surface of the warp yarn and that is called the covering sizing, and therefore, it has the two together have a very good effect on the quality and processing cost in the sizing process. Desizing. Desizing is a process of removal of sizing chemicals from the warp yarn. Before weaving, sizing agents, usually natural or modified starches, polyvinyl alcohol, carboxymethyl cellulose or even guar gum are coated to reduce their functional properties and thus protect the fiber from breaking due to friction. The presence of sizing chemicals on the fiber can act as a barrier for dyeing or printing, and thus it ought to be removed before any further processing. So, for weaving we require sizing agent, but for dyeing and printing we need to remove, and therefore desizing is very important after weaving. So, each step has its own role, each step requires certain chemicals. So, sizing has its own role to play. Desizing is making the fabric prepared for the next steps. Factors to be considered. There are few significant factors to be considered. Type of fiber under consideration. The chemicals used must be selected considering which type of fabric is used and what is the sizing agent. As an example, desizing for modified starch size will be different from polyvinyl alcohol desizing and will vary for cotton fabric and denim as well. So, sizing agent's choice is dependent on the type of fabric. Similarly, the type of sizing agent that has been used will require different process for desizing. Accuracy of manpower. In absence of an automated jigger, the process is highly dependent on people on site, where operators are responsible for the percentage of chemicals used, the percentage of chemical agents and the efforts put into cleaning the desizing machine. So, the desizing process is also very concerted and very well understood, and it has to be that how much of that chemical should be added so that all the size is removed, because for dyeing and printing sizing agent will not be a good desired property. So, desizing process, the complete removal of size is a necessary prerequisite for successful finishing. The chemicals and methods used for desizing depends on the type of size used. Starch and modified starches must be padded with an enzyme and a detergent and allowed to dwell time up to 8 hours. The action of the detergent is to allow the enzyme solution to penetrate into the fabric so as to degrade the starch into constituent sugar units. So, this process requires a long time. It is not just a quick wash. It has to penetrate into the fabric, react on the fabric, break the starch into its soluble sugars, then only desizing will be complete. Removal. Complete degradation is seldom achieving, and the removal of the starch is by reducing the viscosity and solubility, the fragment portions. Acrylic sizes, when used on their own, are very water soluble, and a high removal rate can be achieved by the use of cold water. Heating the rinse water, allowing more complete removal to be achieved at a lower water consumption. So, either we can use hot water with less water, or we can do the desizing removal by using cold water, but large quantities of water would be required. Polyvinyl size can be removed from the fabric by washing at the boil. When PAA, that is polyacrylamide or polyvinyl A alcohol, are used as sizes, they are used by padding and hatching are necessary. Although it will promote gelling of the size, and therefore, it will assist in removal. Removal of sizing agent. In textile processing, sizing agents are substances applied to yarn or fabric to improve its handling and weavability during production. However, there are circumstances where removal of sizing agents become necessary, such as in the preparation for dyeing or finishing processes. Here is a general outline of steps involved in removing sizing agents. So, there is a strategical plan which needs to be followed in order to remove the sizing agent. First is the preparation. Before starting the removal process, it is important to understand the type of sizing agent used, as different agents may require different removal techniques, and that is what I said, that a strategical plan has to be made, which size has to be removed. So, there will be a different plan for removal of starch, there will be a different plan for removal of CMC, there will be a different strategy for polyacrylamides and so on. Common sizing agents include starch, polyvinyl alcohol and synthetic polymers. Pre-treatment. Depending on the type of sizing agent and fabric, pre-treatment may be necessary to facilitate its removal. This could involve soaking the fabric in water or applying specific chemicals to break down the sizing. Removal of sizing agent. Washing. The most common method for removing sizing agent is washing. Fabric is typically washed in water, often with the addition of detergents and surfactants to help dissolve and remove the sizing. The temperature and duration of washing may vary depending on the fabric and sizing agent. Rinsing. After washing, the fabric should be thoroughly washed, rinsed to remove any remaining sizing agent and detergent residues. Multiple rinse cycles may be necessary to ensure complete removal. Drying. Once rinsed, the fabric is dried. Drying methods may include air drying, tumble drying or heat drying, depending on the fabric type and processing requirement. So, we have seen that washing becomes very crucial. Most common method for removing the sizing agent is washing, whether we give it a cold wash or a hot wash. If we are giving a cold wash, more amount of water is required. If we are using hot water, then definitely it would involve lesser amount of water consumption. So, the temperature and the duration of the washing will vary from different size to size and from the fabric type to type. Similarly, rinsing, several times the rinsing has to be done in order to remove the remaining or the remnants of sizing agent with the aid of detergent. Even the detergent residues have to be removed. Drying, once rinsed, the fabric is dried, and so the drying also can be done by air drying, by tumble drying or heat drying. So, the whole idea is sizing is a must, and after the sizing, because that helps in weaving the fabric from the yarn to the fabric, and then once the fabric is made, it also gives good handle for making the fabric, but once the fabric is made, then it has to be washed off and removed completely, because this finishing is very important, because the next step would be dyeing and printing, where the presence of any remnant sizing agent can be very detrimental. So, to conclude, we can say that for quality control, after the removal is complete, it is important to perform quality control check to ensure that sizing agent has been effectively removed. This may involve visual inspection, testing for residual sizing, using specific methods for assessing the fabric's handle and appearance. Further processing, once the sizing agent has been successfully removed, the fabric can proceed to further processing step such as dyeing, printing or finishing. It is worth noting that the specific procedures for removing sizing agents can vary depending on factors such as type of fabric, the type of sizing agent used and the desired end product. In some cases, specialized equipment or chemicals may be required for effective removal. Additionally, environmental consideration should be taken into account when choosing removal methods to minimize water and chemical usage and to ensure compliance with regulation. So, in this chapter, we have learned several new things. We have learned what are the sizing agents that are used, starting from the very common starch, modified starch. Then we learned about polyacrylamide, we learned about CMC, we also learned about DDGS, which is derived from corn, and all of them have some common functionalities. They form a thin film, help the yarn to be woven very well, they control the hairiness on the fabric, which kind of eliminates the defects and so on. And therefore, this particular chapter, which was dedicated for the learning of different sizing agents, is very applicable. Now, I will also further on mention that these sizing agents could be from natural origin or synthetic origin, and we also saw the comparative data of a completely natural sizing agent, which is maize. We saw this, which was another sizing agent, polyvinyl alcohol, which is biodegradable, but not totally natural from natural resource. And there was this synthetic sizing agent, and we saw WSP resin, and we saw the comparison as to I would still go back to that slide, because then it becomes easier to refer to that. This particular slide which we were talking, technical comparison if we want to make of maize starch, PVA and WSP resin. They are from 3 different origin, and you will see that surface smoothness and softness of the size film is poor for maize starch, and it is kind of so for PVA, polyvinyl alcohol, whereas it is for WSP resin it is very good. So, one of the sizes will have some edge over the other, and depending on the fabric quality we need to realize or choose which of the sizing agent is more appropriate. And we saw that how polyacrylate was most suitable for the polymer, polyester and nylon, and therefore, when we are kind of looking at all these fabrics, different types of fabrics, we understand that sizing agent plays a very vital role, particularly for the purpose of weaving the yarn into a fabric, and that stiffness that it provides, the temporary stiffness that it provides is very crucial. So, from this we can say that in this chapter we have learnt that it is worth noting that the specific procedure for removing sizing agent, first applying and then removing, because application is required to carry out weaving process. Then that stiffness is not required any longer for dyeing and printing. So, it has to be removed. Removal is also, desizing is equally important, and both of them generate lot of effluent. These processes are water intensive, and we also saw that if we use cold water for desizing, it requires larger volumes of water, whereas if we require or if we use hot water, it will require less water. And more importantly, the quality control, because after all, why are we doing this sizing exercise? We are doing this sizing exercise on the yarns to make it a good fabric. So, a quality control of seeing that the removal process is complete, because the next step does not require any sizing agent. So, therefore, it is important to see that the removal is complete. First, the adheration of the sizing agent, uniform film formation, so that the yarn can be woven into a fabric is a must. Then the step comes where removal of the sizing agent is equally important. So, with this we have come to an end of this lecture, and we have understood the importance of sizing agent, the role of sizing agent, and the removal of sizing agent and its importance to make the fabric ready for the next step. So, with this we have come to an end. Thank you.